welcome to today's class. We are going to be looking at mathematics today. We're going to take a very sensitive topic. Remember, in JAMB, there are topics that you can never shy away from. Topics like measuration, topics like circuit geometry. In this place, we are not going to waste your time. We will only teach you the necessary and the most important topics that you need for your success. So today, we are going to be looking at circuit geometry. We're looking at circuit geometry, and I believe most of you are familiar with it. Circuit geometry is about theorems. It has more than 14 theorems. Now, this class, we're not going to rush you. We're going to break this class probably into 2 or 3 parts. But I believe at the end of the day, you all will smile. I believe we're with our past questions right now. So when you're with your past question and if you're ready, let us know. Now, we all know what is called a circle. A circle is a plane figure that looks like this. This is a circle, a plane figure that looks like this. Now, the center, remember, at every point, once you see something like this, you know it indicates the center of the circle. That is the center of the circle. Now, let me quickly define some lines that are supposed to this circle. Now, if I have a line drawn from the center to any point on the circumference, this is called the circumference of the circle, which is also the perimeter of the circle. That line is called a radius. That line is called a radius. That line is called a radius. Now, if I draw a line from one end of the circle to another line and dividing the circle into 2 uneven parts, that line is called a chord. A chord is a line that divides the circle into 2 parts. Now, these 2 parts come in 2 ways. The first one is that it divides the circle into 2 uneven parts. The second one is that it divides the circle into 2 equal parts. Now, it's only one line that divides the circle into 2 equal parts. And that line is called a diameter. It's called a diameter. This is a diameter. It's called a diameter. Are you with me? It is called a diameter. A diameter is a line that divides the circle. Remember this, don't forget, a diameter is a chord. It's a type of chord, a special kind of chord, the only chord that divides a circle into 2 equal parts, or what we call a semicircle. Are you with me? Whereas the chord, the ordinary chord that is not a diameter, chord that is not a diameter, divides the circle into 2 unequal parts. Now, we have another line that is drawn across in that fashion. That is called a secant. It's called a secant. And another one that is drawn in this point that touches the circumference at one point is called a tangent. It's called a tangent. Is that clear? Now, these are the lines that we'll be looking at. These lines are the lines we're going to be dealing with in this particular topic. So right now, without wasting much time, we're going to start with the theorem. So let's look at the first one. We call it theorem 1. Theorem 1. Theorem 1. What does theorem 1 say? It says that a line drawn from the center of the circle touches a chord which is not a diameter. Touches a chord which is not a diameter at right angle, that is at 90 degrees, and divide the chord into 2 equal parts. That is theorem 1. A line drawn from the center of the circle touches a chord which is not a diameter. Now, this line divides the chord into 2 equal parts and also touches that chord at 90 degrees, that is at right angle. So this is the first theorem. Now we're going to take a diagram to illustrate this theorem. This is the center of the circle. Now, this is a chord. A line drawn from the center touches a chord. You can see the chord at 90 degrees and divides the chord into two equal parts. Now look at it. Now if we're going to write this, we're going to define this. We'll say line AM is equal to line MB. And at the same time, we'll say angle OMA equals to angle OMB, which is equal to 90 degrees. These are the things we need to know about the first theorem. So quickly, without wasting much time, let's take one example and we'll move straight to the second theorem. We have a lot of theorems to talk about. So let's take examples for the first theorem. Example. Find the length of a chord find the length of a chord of a circle of radius 5 centimeters, and if the distance from the center of the circle to the chord is 4 centimeters. Now, what is the first thing we do? We draw our diagram to represent the position on the chord. We have a chord. We're told that this is the center. This line is 4 centimeters. Now, any line drawn from the center to the radius into the circumference is called the radius, and that is 5 centimeters. We are asked to calculate the length of the chord. Now, if you remember, we are told that this line divides the chord into two equal parts. So the only one we can actually do right now is to get half of the chord, then we multiply by 2 to get the length of the full chord. Now, if you look at this diagram, let me label this part as AM. Now, look at the diagram, you'll find that we have a triangle OAM. Now, if I produce a triangle OAM, O. So this is 5 centimeters, this is 4 centimeters. Now, because this triangle is a right angle triangle, we're going to make use of what we call Pythagoras theorem. Now, quickly, let me quickly deviate so that I will enlighten you to some things about triangle. Now, we have 4 formulas we use for solving questions on triangle, the sides and the angles. Now, we have the Pythagoras theorem. We have SOHCAHTOA. We have the sine rule. We have the cosine rule. Now, listen up, please don't make mistakes. In JAMB, or most especially, this one for JAMB YX student. If you're doing YX and you're solving a question, and you're asked to solve a particular question or given a question on triangle. Now, if that triangle is not the right angle triangle, if it's not a right angle triangle, I repeat, if that triangle is not the right angle triangle, please make do with these two, the sine rule and the what? cosine rule. But if it is a right angle triangle, you may do with Pythagoras theorem or Socatoire. I believe we know the meaning of Socatoire. But as we progress, we're going to talk about all these things and we'll know them very well. Thank you very much. I believe you have learned something there. So you tell them, by applying Pythagoras theorem, which says that what? The square of the hypotenuse side is equal to the sum of the square of the opposite side and the what? Adjacent side. Are we together? So if you look at our triangle, the hypotenuse side is always the longest side of the triangle. So the hypotenuse side is our 5 centimeter. Now the opposite will be our 4 centimeter, and we're looking for the adjacent side. So without wasting time, right, 5 squared equals to 4 squared plus adjacent square. If I now make the adjacent square subject of the formula, I'm going to have 5 squared is 25 minus 4 squared is what? 16. Adjacent square will equal to what? 9. So if I now say adjacent square, taking the square root of both sides, I'll say the square root of 9, which happens to be what? 3 centimeters. Now, half of the chord is 3 centimeters. That is AM. So, and for AB will not be, length of the chord AB will be equal to 2 times 3, which is what? 6 centimeters. This is the length of the chord from the question given to us. This is the length of the chord from the question given to us. So without wasting much time, I believe we've all taken note of all this. So let me clean and let's go to the second theorem. I will take another example. I will go to the next one until we finish the theorems. Now let's look at theorem 2. Theorem 2. Theorem 2. What does theorem 2 state? Theorem 2 states that the angle which a circle subtends the angle which an arm of a circle, the angle which an arm of a circle subtend at its center is twice the angle which it subtend at any point on its circumference. Now, this particular one is very tricky. Very, very tricky. You need to be very careful. Now, let me show you something. This is the circle. Remember, our center is always there. So, alright, this is the diagram we're going to be using. Now, if you notice something, we have two triangles there. We have triangle AOB and COB. Now, these triangles is called isosceles triangle. That is, their base angles are equal. So if this is x, this will also be x. If this is y, this one will also be what? Y. Are you following? Now, as we're looking at it now, if you look at this, there's an exterior angle here, external angle. Now, according to the law of triangle, the sum of two opposite interior angles of a triangle is equal to the what? Exterior angle. So the sum of these two, x plus x is what? 2x. So we have 2x here. Y plus y is 2y. Are we together? So we're looking at the angle which is obtained at this place is twice the angle is obtained at any point on the circumference. Is twice the angle is obtained at any point on the circumference. Are we together? This one is 2 times this one. That's what this particular law is what talking about. Now, proving this thing will not really matter for now, but we're doing JAMB. All we need to know is to get the facts. To get the what? The facts. So what is the facts? Quickly, let's look at a very good example so that it will be clearer to us. That's the center. Now, if we are given that this particular angle is 80 degrees Celsius, this angle is x, this angle is y, this angle is z, and we're asked to find x, y, z, x, y, z. Now, let's quickly look at the theorem. Says the angle which is obtained at the center is twice the angle at the circumference. Now, this 80 degree is twice either y or x. So how do we know which one is which? How do we know which one is which? It's very simple. Now, let me show you a simple trick on how to do this. Now, look at angle 80 degrees. Angle 80 degrees sitting on top of the angle. Now, look at y and x. Y is sitting on top, whereas x is underneath. Now, do you understand? Z is also underneath. So how do we know which one is related? Now, it's very simple, like I told you. The on top, the angles sitting on top are related. The angles sitting under are what? Related. Is that clear? That means 80 is related to what? Y. 80 is related to what? Y. So angle y will be equal to what? Y will be equal to 2 times what? 80, which is equal to 160 degrees. 2 times 80 equals 160 degrees. Now, angle at a point. Now, once you write this, please remember, you must tell them why did you say 2 times 80? By giving them this reason. You write this theorem as your reason. You tell them from theorem 2, the angle at the center is twice the angle at the what? Circumference. That is why you have 2 times 80. Now, what of x? Y plus x is equal to 360 degrees. Why? Why? Now, the y is this. You tell them the angle at a point is equal to 360 degrees. Is equal to 360 degrees. So that everybody will know that. Once they are marking, they will know this is okay, this is why it is this. So our x will be 360 minus 160. 360 minus 160 will give us x to be equal to what? 200 degrees. 200 degrees. So if we got the x to be 200 degrees, which is under, what will be our z? Our z will be equal to half x, which is equal to 1 over 2 times 200, which will give us what? 100 degrees. Very simple. You can see it. Very, very what? Simple. There is nothing to think about it. All I need you to note, all I need you to know is that angles on top are related to angles on top. Angles under are related to angles under. Just note that. Check any past question. Take your past question, look at it. Now remember that all these theorems, they can bring 4 theorems in one question. in one question. So all these theorems, you must know them, know how to utilize them very, very well. Know how to utilize them very, very well. So this is theorem 2, and this is the example we're going to be looking at. Like I told you, always bring in your questions. Ask questions online. Send your questions. We'll try and solve your question as soon as possible. Quickly, let's move to theorem 3. Let's move to theorem 3. Hope we're progressing. Let's move to theorem 3. Theorem 3 says that angles in the same segment are equal. Angles in the same segment are equal. What do we mean by segments? Let me show you. What is segment? This word. What is segment? Now look at this. A chord. This chord has divided this circle into two unequal parts. Now this major part, this big part, is called major segment. And this is a minor segment. Now, what is the trick in this question, in this theorem? The trick is the chord. That particular chord that is forming that segment is the most important chord in this particular theorem. You must always remember that chord. Now, the funny part of it is that JAMB will never draw the chord. The chord will not be there, but you have to use your initiative to introduce imaginary chord. I'll give you examples. Once I draw, I'll give you examples. But before that, you know what is a segment? This is a segment. This segment is produced by this chord. Every area here is a major segment. All this one is a minor segment. A different segment. This place is another segment. This is another segment. Hope we know that. Now, let's quickly take one good diagram to illustrate this. This is our center. Now, if you look at this, you will notice that I have my center and I have two eggs there. And my two eggs is underneath. Now look at these eggs here, underneath. So these two eggs related to these eggs and eggs. Now these eggs and these eggs, where are they originating from? They are originating from this point and this point. They are originating from this point A and point B. They are originating from point A and point B. Now, like I told you earlier on, you can see that there is no chord there. You see, let me introduce an imaginary chord. You can see that imaginary chord. Look at one segment and this small part is another segment. Look at one segment and this part is another segment. Is that clear? So you can see the imaginary chord. The A and B. Now, how do you know angles from the same segment? They have the same origin, they have the same starting point and finishing point. Now look at X, it starts from A. X, same X finishes at B. Look at this X, starts from A, the same X finishes at B. They have the same starting point, they have the same finishing point. So let's quickly take examples so that it will make more sense to us. Now let's work with these four angles. I have angle A, B, C, and angle D. Now, which one of these angles are equal? That is, that belongs to the same segment. Which of these angles are equal and belongs to the same segment? Now let's look at their origin. Angle A starts from A. Let me label this one 1. These are the origins we have. 1, 2, 3. Now, angle A starts from 1. Angle A ends at 3. That's for angle A. Let me do it here. Angle A starts at 1 and ends at 3. Angle B start at what? 1, end at 2. Angle C start at 1, end at where? 3. Angle D start at 2, end at where? 3. Now, which one do you think belongs to the same segment? Angle A and angle what? C. So A is equal to what? C. A is equal to C. Why? Angles in the same segment. I believe you understand what I've just done. Angles in the same segment. Is that clear? Angles in the same segment. So, with that explanation, let's move to another theorem. That's theorem number 4. Theorem number 4. Please follow up, ask questions. Once we are done with theorem 4, we will now go to our past questions and look at the questions we have there. Theorem 4. Are we ready? Theorem 4 says that angle in a semicircle is equal to 90 degrees. Angle in a semicircle is equal to 90 degrees. So let's look at it. This is a diameter. This is the center. This is the 0. Now, if I draw a line like this and I bring it here, this angle here is equal to 90 degrees. Now, we can prove that if this is our diameter, this angle here is what? 180 degrees. Can you see it? It's 180 degrees. That means if I divide it by 2, I will get here to what? 90 degrees. If I do another one in this fashion, this one is also 90 degrees because this one is 180 degrees. Remember I told you, this 90 degrees is on top of the angle. This 180 is also on top of the angle, so they are related. This one is under the angle, this is under the angle, they are also related. Is that clear? So as it is now, we don't need to waste much time. We will get our past question and we'll take questions and you see how we apply this theorem in our questions. Thank you very much.